Okay, let's get started here. Welcome back after 2 weeks. I don't think I've ever taught a class before where I've had like a 2-week break between particular classes. So today we were going to start discussing various career paths. It was, as I mentioned in my listserv post, it was good to see all of you mostly having a general idea of what you would like to do with a degree, at least one idea. I still think that this section will help you because maybe you end up changing your mind, or maybe you'll learn more about a particular career path that you had chosen they didn't know about before. The next assignment for this class is available on the course website. Please note that I updated it on, I think it was Friday, might have been Thursday of last week. So there's some small changes to it. So if you happen to have downloaded before that, please download it again. We will spend some time at the end of class discussing this assignment. So are there any questions before we get going here, or any questions in general about, I guess, our STAT program? Okay. I hope your semester's off to a good start. I hope STAT 882 homework hasn't been too overwhelming. So we just barely talked about career paths last time. Overall, you can roughly categorize the career paths as industry, government, and academia. Where the industry career path corresponds to basically a statistician working in any kind of company-like situation, such as, let's say, working for Google or Facebook, working for Hallmark Cards in Kansas City, working for Target up in the Twin Cities, working for ConAgra, for example, in Omaha or Chicago. So those are some examples of working in industry, and the largest. And so, as you might expect, there's a lot of diverse possibilities, so we can't discuss every single possibility of working in industry. So what I'm going to do is focus on one, the largest in terms of opportunities for statisticians, also in terms of salary as well. And this area is in the pharmaceutical industry. The reason why statisticians are in such great demand by pharmaceutical companies is because the Food and Drug Administration, or the FDA, requires that all new drug products to be safe and effective. And a statistician is an extremely important member of a team of people at a pharmaceutical company that makes that decision, and then the pharmaceutical company then says, okay, we think everything's good with this, we're going to submit it to the FDA for approval. And in the end, the statistician will be involved with, for example, the clinical trial process, like deciding, well, what is a good sample size to use in this clinical trial so that we have a particular power in making a particular, hopefully, a particular kind of statement that the drug is effective. Then the statistician is obviously then the one who's involved in actually analyzing the data once it comes in from a clinical trial. Now, there are two main kinds of companies in the pharmaceutical industry that are involved with the drug approval process and where statisticians work. The first one is a pharmaceutical company, as you might expect. Examples that you might have heard before include like Pfizer, Novartis, and Merck. These are the companies that have come up with a chemical formulation for a new drug. They are also the ones who are in charge of a particular clinical trial process to evaluate if a new drug is safe and effective. They are the ones who are in charge of manufacturing the drug. They are the ones that are in charge of monitoring the safety of the drug after it has been released to the general public. And also they're in charge of, like, say, marketing the drug. That's what a pharmaceutical company does. They're involved from the beginning to the end. Now, there are also what are called contract research organizations, or CROs for short. These are companies that are hired by pharmaceutical companies to, for example, help them with the clinical trial process. So for example, let's say a pharmaceutical company is working on a new drug and they want to run a clinical trial, but they decide, okay, we just don't have the resources right now in terms of statisticians who are working on it or the actual administering the clinical trial. They don't have the resources right now to do it. So what they'll do is they'll contract out, they'll source out their work to a CRO. This, over the years, is becoming more and more prevalent. Now, working at these pharmaceutical companies and CROs, I'm going to take it more from a pharmaceutical company perspective, so I know more about that, it's a very good job in terms of salary, in terms of benefits. So for example, I worked at a pharmaceutical company who had its headquarters in Kansas City when I was a student. And it was a big college-like campus where there's a few thousand people that worked there. We had multiple cafeterias. We had an actual store where we can go get the company manufactured drugs at a discounted price. There was gym facilities. It was really, really nice. But, and this is true, I think to some respect in any job in industry, but I think especially pharmaceutical. I don't know, are you seeing that too? Well, let's try a highlighter to see what happens. Okay, we will close this out. Because of course, whenever something goes wrong with the computer, what do? You turn it off or turn it back on or close out the software package and reopen it up. So that's what we're going to do here. That seems to solve most problems. I'm running an old version of PDF Annotator. I need to update it. Just unfortunately have not gotten around to doing it. Let's see what happens. All right. Notice how it automatically straightened it out? It's a cool feature of this software package because oftentimes you can't get it exactly straight. It will actually straighten it out for you if you need to. Anyway, erase that. So working at a pharmaceutical company can be really, really nice. The issue is often job stability. And I'll go back to my experience as an intern. So I worked for a company at the time was called Herx Marion Russell. This was the mid-1990s. It had been recently formed a few years ago after a merger between Marion Merrill Dow, which was a pharmaceutical company, and also another one that dealt with Herx Russell. Okay. Now a few years before that, Marion Pharmaceuticals joined together with Merrill Dow Pharmaceuticals. Marion Pharmaceuticals was based in Kansas City, and that's why this whole Herx Marion Russell was based in Kansas City when I got to it. Just a little side note for those of you who are baseball fans, Marion Pharmaceuticals was started by Ewing Kauffman, who was the one who first started the Kansas City Royals and owned it for many, many years. Anyway, so mid-1990s, Herx Marion Russell, or HMR for short. Now, since I left there, I think there's been at least 3 mergers. Sometimes it's hard to keep track of this. There's been at least 3 mergers involved with this company. And now, essentially, the stat group there is with, I don't know how to pronounce it, but I'll just say Sanofi. And so, what happens when there's mergers between companies? What can happen? People get fired. Or a nice way to put it is that they are going to downsize because they're going to try to take advantage of, now if I have a stat group here and I have a stat group here, well, what can I do? Maybe, do I need them both? Or maybe let's take this stat group here and we're going to move it to this stat group here. So now people who are living in this city are relocated to this city. So job stability in the pharmaceutical industry was an issue then, and it still is now, unfortunately. So just be aware of that. Also, a lot of the pharmaceutical companies, the actual pharmaceutical companies, are actually based on the East Coast. And if you don't mind living on the East Coast, that's fine. but just realize that's where the main ones are located, no longer in Kansas City. Now, statisticians at pharmaceutical companies are engaged in what's often referred to as clinical trial work and non-clinical trial work. So the clinical trial work means basically they're the ones who are, as I said earlier, analyzing the data that's coming in from a clinical, from testing these the drug out on actual humans. So, and I think this is a good place to talk about this if you have maybe heard about this somewhere else by chance. And that is there are typically thought of as 4 phases to the clinical trial process. So phase 1, the drug is tested on a small number of subjects. The word subjects means people who don't have a particular disease that this new drug is meant to actually treat. And the purpose here is primarily just to evaluate its safety. So these are small clinical trials, maybe 50 people or less, or it might be a little bit higher, just to evaluate the safety. So what they will do sometimes is that they will, let's say, give 5 people a 0 milligram dose, let's say, of a particular drug. Then they'll increase it to, then they'll give 5 other people a 3 milligram dose. Then they'll keep on increasing this to other dosage groups. Now they're doing this to keep track of the safety. Eventually, though, in some of the higher dosage groups, you're going to start seeing like side effects. Okay, and how far do they go before those side effects are something that's like, okay, we need to stop. I've read some of these where people are getting kind of sick from this, and that's not necessarily true for all drugs, but I've seen that. Who do you think the people are that are given this drug in a phase 1 clinical trial? So these are people, I didn't word my question very well. So these are people who don't have a disease. So they're looking for volunteers, healthy volunteers. Who are the people that are often participating in this, who are volunteering, saying, yes, give me that drug?
Sell themselves.
People who are willing to sell themselves, oftentimes it's people who maybe unfortunately their financial situation says, well, they're going to probably make some money because these pharmaceutical companies will pay you money to volunteer. Well, yeah, kind of weird to say volunteer, but yes, they are paying you money to do this. What's a particular kind of group of people that often have, let's say, lower income? Students, exactly. I don't know if you've ever seen an ad during your college careers so far where they say, we are looking for healthy volunteers to participate in this clinical trial. And very often these advertisements are geared towards students. Like maybe you might see it at the student union, you might see it in the student newspaper or online news version of the newspaper. That's who they're trying to get. So, come stay at our facilities over the weekend while we give you some new drugs that we're trying out. Seriously, this is what often happens. So if everything's okay with phase 1, then they go to phase 2, and that is the drug is tested on a number of patients, people who actually have a particular condition that the drug is meant to treat. And now not only are they evaluating the safety, but they're also evaluating the effectiveness. These are typically small clinical trials in terms of the number of people involved. And then if everything is still working out okay, they go to a phase 3, and this is where they do large clinical trials where maybe thousands of people are involved. Again, these are people who have the disease. They probably will also do some comparisons to other, let's say, drugs that are meant to treat that same condition too. Again, looking at safety, effectiveness. If everything goes well, then the pharmaceutical company will submit a new drug application to the FDA. Hopefully it gets approved. If it does, then they go to phase 4. And some people say it's just phase 1 through phase 3, but I think more people now are saying there is a phase 4 where they actually define it, where it's the continued monitoring of the safety and effectiveness of the drug, and also maybe marketing studies are done. Because after all, now that pharmaceutical companies can advertise their product, they're often spending millions and millions of dollars of trying to market it to people. If you didn't know this before, but it wasn't until the mid-1990s that the FDA said, yes, you can actually advertise a drug. to people by name. And since then, it's just amazing the amount of advertisements that are out there for it. And I don't know if it's really been to the benefit of people. You know, there's a benefit of now people have a way to better find out that there is a drug that might be able to treat their illness if they didn't really know it actually had a name. But on the other hand, the millions and millions of dollars that are going towards that, who's essentially paying for it in the end? Well, it's the consumer. You know, because they have to come up with the money to advertise, and well, they're going to charge more for the new drug. Okay, so examples of what statisticians do in this kind of a setting, and I kind of said this, is that determine an appropriate sample size of treatment groups for a study so they can come up with some idea of how effective they will be in coming up with a particular conclusion. You know, maybe I want to have an 80% power such that if there is a mean difference between two treatment groups, I'm going to be able to find it. That's the kind of stuff. And for, those of you who are taking the Stat 821 through 823 sequence, you have Wall Street talk a lot probably about power. Also, let's actually compare the mean, you know, maybe the mean results for two treatment groups as well once the data comes in. From my experience, from what I've seen also talking to other people, typically this clinical trial work that a statistician does, it's often very, you know, going into, you know what you're going to do. You know you're going to set up the clinical trial like this way versus another way, because that way's always worked well in the past. You know, so there's less maybe possibility of injecting some kind of innovativeness or making changes to the ways that things have been done in the past with a clinical trial perspective. What I've seen is statisticians find the job of non-clinical trial work a lot more interesting. The problem, though, is that there's a lot more statisticians in the clinical trial work than the non-clinical work. So what is non-clinical trial work? Here are some examples. If you're taking 850 right now, you'll know that we are doing a drug stability example in that class, where what we want to do is figure out what's the expiration date of a particular drug that's being developed. And basically, a regression type of models are used with this. And I might have mentioned this in the 850 class, but I'll say this again here. You know, Walt Stroop has done a lot of work in this. He's had, over the last probably 8 years, he's had 3 PhD students do dissertations on this, including one that just graduated this summer. Also, there are what are called mixture experiments. If you've ever heard of response surface methodology, this is a subset of that. And basically what this means is that you have a number of chemical compounds that are going to go into a new drug that's just being developed, hasn't gone through a clinical trial process yet, but still trying to be formulated. Well, what percentage of the drug should be this active ingredient? What percentage of the drug should be this active ingredient? And so on. So you have these factors. You want to know, well, what's the optimal combination? And that's where these mixture experiments come in. A classic example of this, when this was first explained to me when I was working at the pharmaceutical company, a classic example of this that's outside the pharmaceutical industry is with respect to orange juice. So very often when you buy orange juice, it's a mixture of orange juice and some other stuff that's in there. Well, what's the optimal combination to get up to 100%? And so that's one of the people who first developed a lot of this stuff. His last name's Cornell, was at the University of Florida, so that's why orange juice is mentioned. There are what are called pharmacokinetic experiments, where you want to see, you know, basically what's happening to the drug in the body over time. You know, if you imagine, you know, in your bloodstream, you know, you have this drug in there, and somehow got in there in some way. You want to measure what level of the drug is in the the bloodstream over time, as you might expect. You know, maybe after 2 hours, it's reached its peak. You know, the body has, you know, maybe it was an oral tablet that you took, and eventually, you know, through the stomach and stuff, it now has gone into the bloodstream. You know, it takes maybe a few hours to get to a peak, and then over time it's going to go down in terms of the amount that's actually in the bloodstream. Pharmaceutical companies need to know that. So they often use nonlinear regression models for that purpose. Obviously, quality control, manufacturing the drug, and then marketing of the drug as well as where statisticians work. Now, these statisticians are typically working in teams of what people often refer to as subject matter experts. So maybe a chemist, maybe a physician, maybe a clinical trial specialist, and so on. So, statisticians are not working alone, they're working in teams. There are both master's and PhD level statisticians that work here. As you might expect with a master's degree, you're not going to necessarily start at the same level as a PhD. But especially because of the great need for statisticians in the pharmaceutical industry, there are ways for master statisticians to eventually get up. And they're not, let's say, having to get to a point where they can't get over because they don't have that PhD degree. But if you're to choose to do this with a master's degree, it's good in the interview process to ask, how far can I advance with a master's degree rather than a PhD? It's an essential thing to ask. So as I said, there's many other areas where statisticians work in industry. While I'm not going to force you, I do recommend that you take a look at Chapter 2 of our book for this class. It has some decent discussions in there. Also, the American Statistical Association, they have a nice web page. Which industries employ statisticians? And so, if you think that you want to work in industry, go find, your application that you're interested in. Go find it on that web page and read about it. Here's a list of companies that employ statisticians, just ones that were, there's hundreds, probably thousands of companies that do it. I just decided to list a few where I was trying to think of, ones where maybe some of our recent graduates or people that I know from around here are actually working. So, for example, Cabela's in Sidney, Nebraska. I don't know why I spelled it wrong first. And also in Lincoln. If you don't know what Cabela's is, it's basically a clothing store. And also they focus on various things associated with hunting. They have stores all over the country, and we've had a number of our graduates work there and are working out in Sidney right now. Cellurone is a CRO in Lincoln. Let's see. Experian deals with marketing in Lincoln. I mentioned this one earlier. I've had a friend work at Hallmark, and what he was doing was marketing. That's what their primary thing there was. These kinds of companies, they want people to buy their product. Well, how can we, formulate a product? How can we, or display to get people to buy it? So he worked at Hallmark for quite a few years, and that's where their corporate headquarters are. And also now he works at Target in the Twin Cities as well. Again, another marketing-like position. Okay, are there any questions? Okay, let's go on to the second main area where statisticians work. This is in government. And again, to try to help you make sense of this, I've done another little categorization here. It's not necessarily perfect, but I think it works. And that is, people in government either work in official statistics or they are engaged in research. The name research is probably more difficult to define than what you may expect. Research could be simply, let's say, helping a physician do something by performing a statistical analysis for them, or it could be actually forwarding the statistical science itself by doing something that will eventually get published in a statistical journal. But let's first talk about official statistics. Here's examples of what I mean by official statistics. So for example, well, let me back up a second. So governments need to understand the people that live in their country or their city or their state and so on. They need to understand the needs of the people. They need to understand what the people are doing, and so that they can share that information with businesses, for example. And so, for example, with the Census Bureau, they conduct large surveys to understand the U.S. population, such as the current population survey. They also, let's say, estimate the undercount in the census that occurs in the United States every 10 years. That counts the number of people who live here. The Bureau of Labor Statistics looks at unemployment rates, consumer price indexes. They are trying to estimate them. The Centers for Disease Control and Prevention, they want to estimate the number of chlamydia cases during a year in the United States. Understand trends in influenza. They will look at general health aspects of the population through the National Health and Nutrition Examination Survey, or NHANES for short. I've actually worked with that in my own research. The key thing here is that hopefully you see this. Oops, didn't mean to draw a line through that. You see estimate, estimate, estimate. They are estimating characteristics about the population. That's what people in official statistics do. So this is the official unemployment rate for the United States at this point in time. That's where this name comes from. So you can see there's a quite diverse set of things that they will do in government. You know, do people in the CDC necessarily talk to people in the Bureau of Labor Statistics? Do they necessarily talk to people in the Census Bureau? Well, maybe a little bit, but not necessarily maybe as much as you would expect that two people who are statisticians would. And so there is a federal committee on statistical methodology that's meant to try to help coordinate what is done in a statistical context in government. In other countries, I think it's coordinated a little bit more. So, for example, in Canada, there's something called Statistics Canada, which basically takes a role of a lot of these different organizations. And if you take a look at this particular website here, you'll see a long list of organizations in the U.S. government, that is, that are dealing with statistics, that have statisticians working for them. Some of those organizations are not necessarily obvious that, yes, a statistician is greatly needed. But if you look a little bit more closely, you can see, yes, that is true. One example is with the U.S. Department of Agriculture. Now, on the surface, especially if you don't know much about agriculture, you might be thinking, well, what does planting beans or wheat really have to do with a statistician? Well, the thing, though, is the government needs to know, well, how much is being planted, for example. How good are we doing every year in terms of yield and stuff like that. So that's where then the National Agricultural Statistics Service within the Department of Agriculture comes into play. Over the last 10 years, we've actually had 2 of our students have internships there. And I just point this out because since we've had interns there, and also because they have some nice descriptions on their website. So the website that I have in the notes, I encourage you to take a look at, will take you to this right here. And if I page down a little bit, it says, well, what do we do? Well, we collect, assemble, analyze, and disseminate up-to-date comprehensive data about U.S. agriculture. It takes a statistician to do that. Here's what our staff is. Well, we have agricultural or survey statisticians. We also have mathematical statisticians as well. So those are the types of jobs that are employed there. Now again, statisticians work often in teams of other people, so there will be subject matter experts that they're working with to do some of this stuff. But also in official statistics, very, very often there are what are called complex survey sampling techniques used. Does anyone by chance know what I mean by complex survey sampling? Okay. So in all of your classes, you've learned about a simple random sample. Okay, what does that mean? Well, that means basically you are, let's say we're sampling people. You are essentially sampling people from a population where every person has an equal probability of being included in the sample. And also what you're doing is assuming that the population is infinitely large. If it wasn't infinitely large, you have a finite population, which of course everything is finite population. Have you ever heard of the finite population correction factor for estimating a variance? Okay, that's where that comes in then. Instead of having an infinitely large sample, you have a finite large sample, and you have to do a little correction to get that variance to be a better estimate. Well, where complex survey sampling comes in is instead of let's say that every single person has an equal probability of being chosen. Instead, people have different probabilities of being chosen. Well, why would you want to do that? Well, let's say that you want to, have a better precision in a particular estimate for a particular area of the country, for sampling people in the country, than maybe in another area. That might be one reason. But it also might be in terms of, what is easier to do in a survey. So let's say that we needed to survey people in Lincoln. Well, and we want, 1,000 people for some reason. What could we do? Well, we can essentially, give everyone an equal probability of being chosen, and then we walk over to their house or apartment or wherever they're living and ask them a question that's on the survey. Alternatively, what's easier to do is to do a multi-stage sampling process, where instead of looking at the entire city of Lincoln, how about you first break up areas of Lincoln into neighborhoods. And so, for example, I live in the North Hills neighborhood in Lincoln, northern Lincoln. So maybe they choose the North Hills neighborhood, and they choose maybe a few other neighborhoods in Lincoln. Okay. Now, within the neighborhood itself, they need to get some people. How could they do that? Maybe they pick a particular street. Okay. And people live on, I live on Mission Lane, so maybe they're just going to ask people on Mission, then they go to every single house on Mission Lane. Now, since that's not a simple random sample, that's going to screw up some of the normal techniques that one would use to do estimation, for example. And so you need to account for that. And that's the purpose of a course like STAT, I think it's 804 in our department. It's a survey sampling course. So people in official statistics often deal with those kinds of aspects that are in a survey sampling course. So if you find official statistics interesting, what course should you take? The survey sampling course. Okay. Other places where the statisticians work, of course, Statistics Canada, but the United Nations. UK has something like Statistics Canada as well. Okay, so that's official statistics. Let's talk about research now. This means a statistician is working to do research at a government agency. So, for example, the National Institutes of Health, which has various locations, but the main locations in the D.C. area. The National Institutes of Health is broken up into different institutes. So, for example, in the grant that I recently got funded, I mentioned in our departmental seminar a couple weeks ago, I'm funded by the National Institute of Allergy and Infectious Diseases, NIAID. But there's also the National Institute of Child Health and Human Development. There's a National Cancer Institute. There's a National Heart, Lung, and Blood Institute. All these, or many of these institutes, have groups of statisticians working for them. So in particular, the Biostatistics and Bioinformatics branch, the BBB, they have quite a few statisticians working for them, and I think I have that up. One reason why I know this is because they're actually interested in my research, and they've talked to me a number of times. And this is where I can't necessarily force you to do this, but this is where the purpose of this class is to benefit you. Go to these websites that I'm putting up here. Read about what they do. Take a look at. Let's see now. Is that so? Their staff. take a look at the individual web pages, and you can see more about what they do, and maybe what they're doing is actually interests you. And, you could even have email addresses there. You could always email them and say, hey, do you by chance have any internship opportunities available? That's one way to try to find an internship. I've done that myself as a student. So anyway, one of our guest speakers this semester actually has part of his job in this particular institute. So those are medical applications that are government related where there is statisticians working. Another example of a medical application is, well, the Food and Drug Administration. Well, if new drug applications are going to the FDA, you need statisticians to evaluate them. But outside of medical applications, there are a number of laboratories that the government runs where there are statisticians working there. So for example, the National Institute of Standards and Technology, which is based in Gaithersburg, Maryland, is one. And instead of working like with maybe physicians, like they often do at NIH, instead they're working with engineers. So for example, they might look at the reliability of software there, for example. In fact, they hosted a Use R conference there a few years ago that I actually attended. The Department of Energy has a number of laboratories around the United States. By the way, these laboratories often will have internships for statisticians there too. I actually worked at the Idaho National Laboratory when I was a student. And what I did was I was working with engineers there. What we were trying to do, my main project I was working on, we were trying to look at unexploded artillery shells. And we wanted to know what's inside them. You know, just from looking at an artillery shell, imagine you're on a battlefield, looking at an artillery shell, hopefully you're not going to touch it. You never know what might happen. You know, just looking at it, can you figure out, well, what's inside it? No, maybe, maybe not. Probably not, you know, if it's from an enemy. And so what we were trying to do was come up with ways to bounce sound waves off those artillery shells to determine what's inside it. And so we had a classification problem essentially. You know, is it mustard gas? Is it empty? Or is there something else inside of there? And so I was a statistician working with engineers on that kind of a project. Let's see. Also, there's many nonprofit organizations that perform government-like research. So, for example, one of our graduates, Reed Landis, he just recently got back, maybe in the last 2 years, from working in Japan for a couple years. He was working in Hiroshima, and part of his job was to work in the statistics group to evaluate, you know, the various effects of radiation from the atomic bomb that was dropped there in 1945. And so you can read more about what he did at that address. Okay, so lastly, academia. About half of you indicated that you're interested in academia, so we'll spend some time on that. And obviously, since I'm in academia, I know a lot about academia. But before I get to that, though, I want to jump ahead to help you out, to talk about something else that will help you with the next assignment. So we are going to go to this page here. That's page 15. Now, originally when I put these notes together, I was actually going to do this lecture after I did another lecture on professional societies for statisticians. And so there are a few places here where, unfortunately, I did not update my notes properly. And I'm assuming, okay, you already know what this is, but we haven't talked about it now, actually, in our class. So I will try to add information as needed. Okay, so resources to find jobs or job announcements. You know, who's advertising that I have a job available for you? That's a statistician. And so where can you go to find this information out? One of the best places is AMSTAT News. So AMSTAT News is a monthly publication of the American Statistical Association. And at the end of it, they always have job announcements. Now, they also put these job announcements on a particular website, so you don't actually have to go in and download a copy of the AMSTAT news. And so this is the actual website that I give in the notes. So if I go to ASA Job Web, get started now. Here you're going to start seeing job announcements. So if I come over here to, they're looking for professors at every level at the University of Iowa in the Department of Biostatistics. I can click on that, and you have the job announcement. It gives you obviously information about what they're looking for and also how to apply. Okay. And so this is a great resource to look for job announcements. In terms of university websites, the best one out there is the University of Florida. It seems like most people always send their job announcement to University of Florida, and they have a nice job website there. One reason why they do that is because it's free, and everyone who has experience, knows about it. So this is another great resource. Less publicized is the Purdue website, but they organize it nicely, so that's why I mentioned it. Also, there's a lot of job interviewing done at the Joint Statistical Meetings, that's JSM, and the ENAR meetings, that's the Eastern North American region of the International Biometric Society. JSM, we just had it last month. There was over 7,000 statisticians in Chicago at this week-long meeting. The ENAR meetings, you'll have over 1,000 statisticians there. And the next one's coming up in DC in March. And I'll talk more about that when we discuss these meetings in more detail, but basically employers go there to interview people for jobs that they have open. Because this is a great time where a bunch of statisticians are getting together. LinkedIn, that is a great place to find jobs as well. In preparing this set of lecture notes, I talked to some of our graduates about what they would recommend. And so David Johnson from 2006, this is what he said. I'll let you read that on your own about how good LinkedIn is for getting a job in statistics. Just out of curiosity, not because I was interested in looking for a new job in Illinois, but just out of curiosity, I decided to go ahead and just show you, well, what would happen if one looked for a new job in Illinois. The reason why I did that is because that's where David's located right now. And I know that's kind of small. What's up? But this is what I got from a simple search for statistician, Illinois. So, for example, here is a pharmaceutical job in industry. Here is probably marketing at ConAgra in Chicago. Here is, let's see now, financial in Chicago. Here is a programming position in Chicago, or Chicago area. There are tons and tons of opportunities out there. LinkedIn is a great place to look. Be on the lookout for job announcements that are sent to us in the Department of Statistics. Typically, our secretaries will circulate them among students, so make sure our secretaries have your correct email addresses as well. Now, one way that some statisticians find jobs is to use a search firm, otherwise known as a recruiter, otherwise known as a headhunter. I don't know if I would, I don't think I would probably do this just because there's so many opportunities out there, but I know some of our graduates have. And basically, these search firms will try to find a position that matches your needs. And what do they get out of it? Well, they get maybe 20% of your base salary from the first year that the company will pay them. You don't have to pay them that, though. One example of one of these search firms is Analytic Recruiting. Well, what about salary? Some of this I'm going to skip for now and come back to it. But what I do want to mention is the American Statistical Association publishes salary surveys. Now, I noticed in a number of your last assignments, some of your salaries maybe were not necessarily reasonable from what you actually had put down. And so what I encourage you to do is take a look at the salary surveys that are available on their website so you have a better idea, well, what kind of a salary should I expect when I get done with my degree here. Let's see here. Also, academic, I'll save that for another time. Let's see, have I talked about enough so that we can talk about the assignment? Yep, I think I have. Okay, so let's take a look at the assignment. So again, you can download this from the website. Problem number 1. And tentatively, this is due Wednesday. And I didn't write it on here, but I know it's on the web page. It's tentatively due Wednesday, September 21st at noon. Okay, again, handed in to me in a similar manner as last time. Work alone on this assignment. So problem number 1, find one job announcement for each of the 3 career path categories: industry, government, and academia. I've given you some sources where you can find job announcements. Don't just take the first one that you see. Look through them. Find something that would actually maybe interest you at this time. Take advantage of this opportunity to do this. Give me a web link to that announcement, but also give me a screen capture. The reason why I had that is because sometimes maybe a job announcement by the time I get to grade it might no longer be active anymore. So that screen capture helps me see what it was. Include or use at least 2 different resources when finding these announcements. So maybe you go to the University of Florida website to find a job in industry, and then go to maybe AmStat News to find a job in academia. That's what I'm talking about. I want you to get some exposure to more than one resource. That's why I have that there. Number 2, join LinkedIn and fill out your profile. Okay. This is a resource that we use as statisticians. So go join LinkedIn, linkedin.com. If you're unsure exactly how to do that, let me know. I'll help you. Include a link to your profile if it's public. If not, that's okay. But in either way, please provide a screen capture of your profile that you have filled in on LinkedIn. If you send me a connection request, I will be happy to accept it. Number 3 here, complete the following questions. These are essentially the ones that you did last time, but maybe after this set of notes you have decided, nope, I'm not going to do that job anymore. I'm going to have to do something else. Or maybe you know more about the kind of position after you take a look at the notes, maybe done some explorations of what these links give you, and maybe you can fill out some of these in a little bit more detail than we had in the past. Part C, though, what salary level will be appropriate for this type of job? Actually use some of the resources that I briefly talked about to try to find better information about what kind of a salary to expect. And then lastly, this is to lead into our next section in our course when we talk about statistical professional societies. I want to know, are you a member of a professional society right now? Tell me, well, why did you join in the first place? Just because your professor told you to? Or did you have a real interest in doing it? Okay, so that's it for today. Are there any questions? Okay, I will see you then next week.